10.6 is about translating ellipses and hyperbolas and the like. And again, it just comes back to the center of HK. Again, you see here x minus k, or I'm sorry, x minus h and y minus k. And if it's the other way, it's x minus h plus y minus k still. But again, notice the b and the a change spots. So again, it's no different than what we did earlier with ellipses. So I'm looking at what is the standard form of ellipse, vertices 1, 6, and 116, and one focus at 114. So what I'm going to do is, because y changes 6 and 16, I'm going to actually find the midpoint. That's going to give me what my a is. So what I'm going to do is find the midpoint of 6 and 16. So let's do 6 plus 16 divided by 2. So 22 divided by 2 is 11. So my midpoint, the center of this vertex, or this ellipse, I'm sorry, is going to be 1, 11. And now you see the y is changing with your vertices, so your foci is up there as well. Okay? So what's A? A is 11 to 16 would be 5. Okay, so if I'm going from this to 16, that's 5, or 11 to 6 is still 5. So my A squared is 25. All right, and what's my C? Well, I'm going from 11 to 14 now. So my C is from 11 to 14, which is 3. So my C squared is 9. So again, we're dealing with ellipses. We're dealing with C squared equals A squared minus B squared. So let's plug this stuff in. C squared is 9 equals 25 minus B squared. Solving it, negative B squared equals negative 16. B squared equals 16. So let's write my equation on my ellipse. We know that x comes first always in an ellipse. So it's x minus 1, opposite in parentheses, squared, and then plus y minus 11, again, opposite in parentheses, squared. Now, which one goes where? Because my vertices on the y, my a goes under the y. So there's 25, my b goes under the x, 16 equals 1. Now, it's a lot of the same stuff for hyperbolas, but remember, it's just a minus sign. That's the only difference. But again, it's still x minus h, y minus k, same difference. If it flips now, the a never changes. See how the a stays put, just like it did with normal hyperbolas, and the y and the x flip. So let's take a look here. Here they give me the equation. They want to know what the center, vertices, foci, and asymptotes are for the hyperbola, for the the hyperbola with that equation. So again, what's my center? It's always h comma k, and the h is always after the x, opposite in parentheses as normal. So my center of this is going to be 3, 1. Vertices always come first, and then if you look here, y is on top. So it's going to affect my y. So since my center is 3, 1, it's going to be 3 and then 1 plus or minus a, which is the square root of 25, so we get 5 here. Okay, so what does that give me? My vertices are going to be 3, 6, and 3, negative 4. Now my foci is still going to be the same thing. Because it's under the y, it's all effect on the y. That 3 is not going to stay the 3 is going to stay the same. It's not going to change. So 3 and then 1 plus or minus, but I got to find out what the heck my c is. Okay? So let's find what my c is. Remember, a squared, c squared equals a squared plus b squared now. We know what those things are, so c squared equals 25 plus 144. So c squared is going to equal 169. Square root both, c is going to equal plus or minus 13. So 1 plus or minus 13 for my foci. So that's going to give me 3, 14, and 3, negative 12 for my foci. If you go back and look, the asymptotes is y minus k. We're dealing with this one right here. Plus or minus a over b, x minus h. So my asymptotes based on that equation is y minus 1 equals square root of 25 is 5 over square root of 144, which is 12, because it's a over b, times x minus h, which in this case is 3. And that would be my equation. And you can stick a plus or minus in front of it, that's enough. Now example 3 kind of puts it all together, and it's going to force us to complete the square here to help us to see what's going on. So let's group our variables and go from there. So 4x squared minus 24x plus leave a space plus y squared plus 6y plus leave a space equals negative 9. I'm going to take the 9 and move it to the other side. Remember, parabolas you didn't, but everything else you should. Okay, so what I'm going to have to do here, though, the only problem here is I can't complete the square with a not being 1. So I'm going to have to pull a 4 out of here. I'm going to divide all this by 4. So when I do that, pull a 4 out here, I get x squared minus 6x plus, still leave your space, plus y squared plus 6y plus leave your space equals negative 9. I have to account for that 4, but we'll get to that in a second. So let's complete the square. It's negative 6 over 2 squared. And then it's 6 over 2 squared again. So what do I have to add here? I still have to do these negative 6 over 2, which is negative 3 squared. But I have to account for this 4, so I need to bring that 4 with it. Plus, and then 3 squared here too as well. So let's factor. I'm going to bring this down. So I'm going to have the 4 is going to stay out there. X minus 3 squared plus, well, there's nothing out there, so I'm going to go y plus 3 squared equals, now all that garbage, whatever you punch in your calculator, it's going to end up giving you 36. So how do I know what I have to do? Well, it could be a circle, it could be an ellipse, it could be a hyperbola, it could be a lot of things. It's definitely not a parabola because of the different two y squareds. I'm sorry, the x squareds and the y squareds. But because I have this 4 here, I want to go ahead and divide by 36. That's going to end up giving me what? Well, let's reduce. It's x minus 3 squared over 9 plus y plus 3 squared over 36 equals 1. Notice how the denominators are different. That means that this is going to be either an ellipse or hyperbola. The plus sign tells me it's an ellipse. Just to refresh your memory, wanted me to find the foci, so c squared equals a squared minus b squared. In an ellipse, the a is the bigger number, so we end up with c squared equals 36 minus 9, which gives me 27. So c equals plus or minus 3 radical 3.